This is example 16.8 from Discovering Design with Chemistry, and you have made it to the last example of the book. Boric acid is a weak acid that donates only one of its H+ ions. Give the equation that represents its acid ionization constant. So when we're talking about the acid ionization constant, we're talking about its reaction with water. So let's go ahead and combine these. Let's put what form this is in. Plus H2O liquid. We're going to get H3O plus from that. Remember, when we have an H plus, it's going to run from the acid to the base. Like it's playing a game and it's got to run to home base. Alright, so we know that this is also this. And then this one is just down an H. And it's also minus because the H plus left. Alright, so there's our equation. And then we have to figure out what its equation would be for its acid ionization constant. So it wants the K of A, which is going to be the same as its equilibrium constant. So K equals, remember we can ignore the liquid, so we're going to mark that one out. So H3O plus equilibrium times H2BO3 equilibrium. Those came from the product side. And then we're going to divide that from the reactants, which is just the one that is not a solid or a liquid. All right, so that's the equation for its acid ionization constant. A little K here. I mean a little A here. All right, the next one down here uses a picture from the book on page 504 that has a bunch of little beakers listed. I was not going to try to find a picture to match. And it has pH 1, 3, 5, 7, 9, 11, 13. And in the text, it already discussed the first one, pH 1, and that it was HBr, and the pH 3 was acetic acid. And in the text, it also told us that the ionization constant for the acid ionization constant for the acetic acid was Ka equals 0.000018 m. So we're going to use that information. So I want to go ahead and collect it so that it would be easier to without having to flip back in the book and see. Okay, so we are told that it is pH 5, and on the scale we have 1, 3, 5, 7 is like our, kind of in the middle, 9, 11, 13, and so this one is very close to the middle. So it's a weak acid, so it's not going to have a large equilibrium constant. So we can go ahead and rule that one out. Between these two, which are both small, I mean they're less than 1. How small is it? We can use the acetic acid number that we have here to help us figure that out. So it needs to be, to have a higher pH, the boric acid must be weaker than the acetic acid. Since they both have, all three of these, by the way, had 0.1 molarity, so they all have the same concentration. So to have a higher thing, its acid ionization constant has to be less than acetic acids. So this one is, compared to these two, if we looked at them, this one is 5 thousandths. This one is 18 thousandths. Okay, this one's like 18 millionths or something like that. This one's definitely, if we put them in line in order from smallest to largest, this one would be smallest, this one would be medium, this one would be the largest number. So we need it to be smaller than acetic acid to be a weaker acid. So what's smaller than medium? The small. And that's the end of the problem. So, weaker acid is going to have a smaller Kva. And then a stronger acid goes the other way. Stronger is going to have a larger.